Good day, Mr. Aller. So for today, our group will be discussing about the Smart Traffic Lights initiative in Metro Manila. This initiative is happening right here in Metro Manila, particularly in highly congested areas such as the cities of Manila and Caloocan. For example, the MMDA installed sensor-based traffic lights at specific interchanges along the NLEX connector, which serves about 143,000 vehicles every day. That's a huge number, and managing the traffic efficiently is a big challenge. Metro Manila has long faced serious traffic management issues, and the MMDA designed this project to address several of them. So now let's take a closer look at four key problems they aim to solve. First is heavy congestion and inefficient waiting times at intersections. Before, many of our traffic lights worked on fixed timers, meaning the red, yellow, and green lights changed at the same intervals, no matter how many cars were actually waiting. So this led to traffic buildups even when some lanes had no vehicles at all. With the new adaptive systems, sensors detect how many vehicles are present in each lane and automatically adjust the green light's duration based on actual traffic flow. The second problem was the driver behavior. Before, the old traffic lights had visible countdown timers, which some drivers used to speed up just to beat the red light. The new system removes those countdown timers and instead follows a new sequence. The green light blinks in 5 times, then turns yellow for 3 seconds, and finally red. Third, there were safety concerns not just for the drivers but also for pedestrians. Poorly timed signals used to cause confusion and increase the risk of accidents at busy intersections. With the adaptive traffic lights, pedestrian crossings are better managed and the system ensures safer traffic flow for all road users. And for the last problem, Metro Manila's traffic infrastructure was outdated. Many signal systems hadn't kept up with our city's rapid growth in vehicles, population, and urbanization. The realized it was time for an upgrade, replacing old timer-based systems at 96 intersections with smart sensor-driven ones. According to recent reports, up to 90% of intersections under MMDA's control have now been converted to adaptive traffic lights. So why go smart? Instead of widening roads or building new ones, which takes time and costs a lot, the MMDA decided to optimize what we already have. By making traffic lights smarter, the city can first reduce vehicle delays, second improve traffic flow, third enhance road safety, and make better use of existing infrastructure. In conclusion, the Smart Traffic Light Initiative is a major step forward for Metro Manila. It shows how technology can be used to solve urban challenges, improve safety, and make our daily commutes a little less stressful. Though traffic remains a big issue, this project brings us closer to a more efficient and adaptive traffic management system.
Next is the AIoT solution. What kind of smart technology was used? So in Metro Manila, the Smart Traffic Lights project was created to help solve serious traffic problems in busy areas like Manila and Caloocan. So the system uses a combination of real-time sensors, loop detectors, and artificial intelligence or AI. So the first technology is the real-time sensors were placed at the intersections to check how many vehicles are waiting in each lane. So this means the system can detect how many cars are waiting in each lane at any moment. So the sensors don't just check once, they keep watching and updating the system in real time. Next is sensors or loop detectors were installed under the road surface to sense when a car passes or stops. So these detectors are placed under the road and can sense when a car drives over or stops on top of them. Next is the artificial intelligence receive the data from the sensors and loop detectors and decide how long each green light should stay on. This is where AI comes in. So it acts like the brain of the system. It takes all the data from the sensors and detectors and makes decision instantly. The AI gives more time to the lane that needs it. This also helps the cars move faster and reduces traffics. Next is the old traffic lights that used fixed timers were removed. So before the light stayed green, yellow, or red for the same amount of time, no matter how many cars were on the road. So this caused long delays and traffic build up even when some lanes had no vehicles. Next is countdown timers were also taken out because they made drivers rush to beat the red light, which led to safety problems. So they removed those timers and replace them with a blinking green light that warns the driver to slow down. And after 5 blinks, it turns yellow for 3 seconds, then red. So this gives drivers enough time to stop safely and helps pedestrians cross without rushing. Next is the whole system runs automatically, so it does not need people to control it. So this means the system doesn't need traffic enforcers or manual control. Everything is connected through internet and the AI handles the decisions. So it's also a fast, automatic, and always based on real-time traffic. So in short, this smart traffic light system helps Metro Manila manage traffic better by reacting to real conditions. So it is a real example also of how AIoT works in cities using sensors, internet connections, and smart decision making to make everyday systems more efficient and more helpful for everyone.
How does the system collect and use data? By the smart traffic lights use sensors, CCTV, and internet to gather continuous data. A predictive system then adjusts signals, sending instruction to a cloud-based transport management system or processing them on-site. Real-time data is used by Manila Traffic Lights System to better control traffic flow. This is a simplified overview of how it works. For the data collection, it includes sensors and detectors. It means they monitor traffic volume, flow, speed, and distance at intersection. Next is CCTV cameras. It provides visual traffic data to the control center. For the data processing and analysis, we have real-time analysis. This is local processing enables immediate response to changing conditions. Second is adaptive signaling. The system adjusts green light timings to optimize traffic flow. And for the data cloud, it sends traffic patterns to the cloud for long-term analysis and future improvements.
The next is system coordination. The traffic lights work together through a central controlled network. They share real-time data so nearby intersections can align their signal changes. This helps reduce unnecessary stops and keeps vehicles moving smoothly on the main roads. The next one is peak hour adjustments. During rush hours, sensors detect when certain lanes have heavier traffic. The green light stays longer for those lanes to ease congestion. When traffic becomes lighter, the timing adjusts again to keep vehicles moving steadily. And lastly, safety and emergency response. The system detects unusual road situations like stalled vehicles or pedestrians crossing outside the lane. It adjusts the signal timing to prevent accidents and can prioritize emergency vehicles like ambulances or fire trucks by changing the lights to let them pass safely.
So to address Metro Manila's long-standing traffic congestion, the MMDA recently upgraded its traffic management by replacing timer-based signals with a sensor-based adaptive system.
According to MMDA Chair Don Ates, the new system expected to reduce congestion, lower accident rates, and reduce vehicle emission by minimizing idling time. The following improvements have been observed. The adaptive traffic light system monitors real-time traffic flow using sensors and AI algorithms by extending green light durations on busier lanes and shortening them where there is a little to no traffic. Lower accident rates. Many traditional traffic lights can make drivers stop suddenly to speed up to get through a light before it turns red. This can lead to more accidents. The new system replaced countdown timers with a better light sequence, a blinking green light, then yellow, and then red. This method helps drivers know when to slow down more clearly. The adaptive timing also reduces problems between vehicles and pedestrians by matching green lights to actual traffic and crossing patterns with which lowers the chance of accidents at busy intersections.
So it also reduced vehicle emissions. So idling at red lights and stop-and-go traffic significantly adds to air pollution in cities because engines do not run well during these times. An adaptive traffic system improves traffic flow and reduces idle time, which lowers harmful exhaust emissions. This helps improve the air quality in Metro Manila and supports efforts to reduce the city's carbon footprint. It also reduces costs for repair. Better traffic conditions means drivers brake and accelerate less often, which reduces wear on brakes, engines, and transmissions. So fewer accidents also mean lower repair costs,
for vehicle owners. And over time, these benefits can make owning and maintaining a vehicle cheaper for both individual drivers and commercial fleets.
In a simple way, though, traffic light modules offer many advantages. They also come with some challenges and drawbacks, and one major issue is the high cost of installing and maintaining this advanced technology. So the traffic light modules can greatly benefit smart city by improving traffic movement and enhancing safety and making transportation system more efficient. So by using this module as part of intelligent transportation system, cities can create a more sustainable and inclusive urban environment. Smart traffic play a vital role in creating modern and efficient cities. They help reduce traffic congestion, lower fuel consumption, and minimize travel time. By adjusting signal patterns based on a real-time traffic condition, this system also improves road safety by detecting pedestrian and emergencies vehicle. And however, to successfully implement smart traffic lights, cities must invest in proper maintenance and reliable sensor and skilled operator to ensure smooth and operation. So, I believe this system will work in Manila City, but it will also face some challenges. Those smart traffic lights could really help in manage heavy traffic, especially during rush hour, and make travel smoother and faster. It will be also very helpful for emergency, like vehicles, ambulance, and fire trucks, and allowing them to reach their destination more quickly and faster. I think the main challenges will be the cost of installation, maintenance, and the need for modern infrastructure to support the system. Some areas might not have the proper equipment, so internet connection needed for the smart technology to function properly.